Okay, I'm going to look at probability trees with these sweets, which are left over in our house from Christmas because nobody likes any of these ones. So we've got some strawberry creams, some orange creams, and some blue ones, which I think are coconut. So not very popular in our house. They've been hanging around since Christmas. Altogether, we have got 10 sweets in the bowl. There's 5 red ones, 3 orange ones and 2 blue ones. So I'm going to look at writing that as probability, as a probability 3. If I was to choose a sweet at random, what would be the probability I would get a red or a blue or an orange? So hopefully you can see this okay. I'm still getting the hang of doing this. So the probability of taking a blue one, which we can write as P brackets blue, is going to be equal to, there's 2 blue sweets out of 10 altogether, so it's 2 out of 10. The probability of taking an orange one, because there are 3 orange sweets out of 10 altogether, is 3 out of 10. And the probability of taking a red one, we can write that as P brackets R for red, is equal to 5 out of 10 because there are 5 red sweets out of 10 altogether. Probability is always written as a fraction or a decimal or a percentage. I could write that as 2 out of 10, I could write that as 0.2, I could write that as 0.3, or I could write that as 0.4, or indeed 20%, 30% and 50%. But I'm just going to stick with fractions for now. So I'm going to fill in my probability tree. So I've got B for blue, O for orange, R for red, and probability of blue is 2 out of 10, orange 3 out of 10, and blue 5 out of 10. So if I was to choose one of those sweets without looking, that's the probability I would get each of those colours. Okay, so I'm going to look now at what would be the probability of me taking 2 the same, assuming I replace the sweet the first time. Okay, so when you replace something in probability, it's quite a different outcome as when you don't replace it. So if I was to replace the sweet, if I took a blue one, I'm just going to add my 3 branches from each of these first branches, because second time round there's still 3 different possibilities. I could take a blue one and then another blue one, an orange one or a red one. I could take an orange one first and then each of the 3 colours, or I could take a red one first and then take blue, orange or red. So I've got all those different possibilities. So if I was to take a blue one, okay, I'm going to put it back. Alright, perhaps I don't like it, but anyway, the key thing is here that I'm replacing it. So because I've replaced it, the probability stays the same. There's still 2 blue sweets, there's still 10 sweets altogether. If I was to take an orange one and then put it back, the probability for orange is going to stay the same. The probability for the other colours is also going to stay the same. Put it back so the probabilities stay exactly the same. So I can just fill that in on my probability tree. So probability of blue second time round, because I've put it back, is still 2 out of 10. Probability of orange is still 3 out of 10. And the probability of red is 5 out of 10. Okay, so at the beginning I said, what's the probability of taking 2 sweets which are the same, assuming that I replace the first one? Okay, so I'm going to look at the probability of taking blue and then blue again. So I'll highlight the branches, blue, blue. And the probability of taking a blue and taking a blue again, I'm going to multiply along the branches, because that's how we calculate the probability of blue first time and blue second time. So the probability of blue, blue is 2/10 times 2/10, which multiplying fractions, we multiply the numerator and multiply the denominators, 4 out of 100. Okay. Probability of orange, orange is 3/10 times 3/10, which 3 times 3 is 9 over 100. And the probability of red, we highlight our red branches, is 5 over 10 times 5 over 10, which is 25 over 100. Okay, so the total probability, we looked at blue, orange, and red, and each of those are ways in which we could end up with two sweets the same, having put one back after the first time. Okay, the probability of the second one we choose being exactly the same is for the blues 4 over 100, for oranges 9 over 100, and for reds 25 over 100. So the probability of two the same, we're going to add up these three fractions. So 4 over 100 plus 9 over 100 plus 25 over 100. Because when we have the probability of two the same, we can have red, or blue, or orange. And when we have a situation where you can have one outcome or another in probability, to find the total probability, we add the probabilities together. So we've got a common denominator of 100. 4 plus 9 is 13, plus 25 is, mine's gone blank, 37 over 100. No, it's not. It's 32. 13 plus 25. 38 over 100. Beg your pardon. Sorry. 38 over 100. So 4 plus 9 is 13, plus 25, 38 over 100. Bit of a mind blank there. To make that nice and clear. Adds up to 38 over 100. So that's the probability of two the same. Okay. If we wanted the probability of two different sweets, then we know that probability always adds up to 1. So we could either have two the same, or we could have two different ones. There isn't any other possibility if we're going to take two sweets. So it always adds up to 1. So to work out the probability of two different ones, we could take 38 over 100 away from 1. So 1 take away 38 over 100. If I write 1 as a fraction with a denominator of 100, that's 100 over 100. And the numerator and denominator are the same. That means it's equal to 1. It's equal to 1 whole. 100 take away 38 is 62 over 100. So the probability of two different sweets is 62 over 100.